Hello and welcome to this episode of our full-text search on entities. In this episode, we're gonna set up ElasticSearch and Kibana, and we're gonna think about how we can search our books best with the helps of the tools that Elastic provides. Therefore, we first gonna have to install ElasticSearch, of course. So go to the official website, which is elastic.co. Then go to Learn and Docs, and here you find the installation guide for the different products that the Elastic company provides. We are only interested in Elastic and Kibana, so I'm gonna check out install the Elastic stack, and here you see the different products. The main one, of course, ElasticSearch, which is the heart and provides search capabilities, and Kibana, which is basically a front end for ElasticSearch. Here you find different variants how you can install it on Linux, Mac, Windows, and in different formats. And I want to use Docker because it basically works on all platforms where Docker is available. And again, you find different ways to install it. One, the probably simplest one to get started, is just a Docker command, which takes a bunch of parameters. And they also provide some slightly outdated version of a Docker Compose file. So I'm gonna use parts of this. Copy that over into my own Docker Compose file. And I will slightly modify the values here. I don't need this value, and I like to give all the services their natural name. So in this case, Elasticsearch. And I'm not going to use an actual cluster like they do here with 3 different instances. That is a bit overkill for my use case. So I'm gonna overwrite this line, and therefore I don't need this one. Maybe give this a little bit more context, like entity search. Just like that. This will limit the amount of heap memory that the JVM can use. The documentation explicitly wants that you should only use this for playing around, so nothing that you should use for production. Okay, so now we also want to have Kibana. So I go back and choose install Kibana. Again, you see different ways to install it. I want to add it to my Docker setup. So this one is pretty simple. Again, copy it over into the Docker Compose file. Make sure it's properly intended. And I'm not going to use the volumes part here. So I again will just overwrite that part. So basically I just map the default port to the host so I can reach it from outside. Okay, and now we're good to basically start our Docker Compose file with these 2 new components. So let's try to open Kibana. As I said, this is a front end for Elasticsearch. And here it is. Kibana provides a bunch of views to discover data in Elasticsearch, but I only want to use it to check out the DevTools. The DevTools are basically a tool provided by Kibana where you can interact with the REST API of Elasticsearch. And I really think it's helpful to play around with that. It's much more convenient than using curl or something, but you could also use Postman if you prefer it. But I like this one because it provides auto-completion. Maybe before we start, we're gonna check out if our cluster setup worked as expected. And that looks pretty good. As you can see, our cluster is named ElasticSearch. This is exactly the name that we provided here. And we also see that the max JVM size is like we defined it. So that looks all pretty good. We have one node running with the name ES1. This is the name given here. So that looks all good. Let's think for a moment about how we want to actually store and search our data. So at the moment, we are only handling the book entity. So I'm going to open that up. And our book entity at the moment only has 3 distinct properties. The ID, which is probably not so interesting for searching by a customer, and the name, which is highly relevant for search by the customer, and some pages. So let's assume that we are interested only in the name. So let's think for a moment about how we would implement an index that is suitable to search for a book name. Therefore, I'm just going to create a new index called book, and I'm also going to input a document with a name. Okay, so that worked fine, and we can also have a look at the content, basically with the same syntax. And here's the result. This is all fine, but of course the most crucial part is that we want to search for our book, and we want to search in a, let's say, very fault-tolerant way. So it should work even when the customer does not exactly know the name or has a typo in it. So Elastic provides a search endpoint on all indexes where we can write some search queries. As you can see, it already provides some useful autocomplete. And let's search for our one and only book, which is Dark Tower. And again, you see the search result. It found exactly one result, and this is the actual list of results, which only contains one entry named Dark Tower. So this worked pretty great. So what happens when the user searches only for one word and the word is even not on the beginning? It still works, so that's pretty good. Let's see what happens when the user does some typo. Okay, now we don't get any result. Even so, the error is only a minor one. Elasticsearch provides some concept of fuzziness, so that we get a result even if the query parameter is not 100% correct. Let's try that out. So we have to use a slightly different syntax, where we add a query here, and again have tower and turn on the fuzziness. But it usually uses one, which basically means you can change one letter, add one or delete one. Let's try that one. And as you can see, now it returns a result again. But if I would add another wrong letter, then it would break. You can increase the fuzziness to 2, but you cannot increase it beyond that. So let's add one more. So 2 is the natural limit of Elasticsearch. And I would even go a step further and provide the order parameter here, because that will apply some smart logic, like a very short term, like only 3 characters, or between 3 and 5 characters, I think, can have a fuzziness of 1, and 6 or more have a fuzziness of 2, which should work fine for most use cases. We already tackled basically the problem of a wildcard search. So the user does not have to match the full name. It can work with only a part. For example, also this would return a result. We also forgiving minor typos. But there's one more problem that is very common when you search any names. And this is not all names are written with the English alphabet. And we want also to find these one easily. So what can we do about that one? So again, I'm going to open the Elastic documentation. What we are actually going to do is related to the Elastic topics of mapping and text analysis. Let's start with text analysis. And Elastic knows a concept called token filter reference. And here you can see it provides basically different functions, how you can process the incoming data to make it easier for the search later to find it. And if we're dealing with characters that are not in the English alphabet, we can use a concept named ASCII folding. And here you already see a pretty good example what it does. So I'm gonna just copy that over so that we see it directly in Kibana. And what this basically does is it provides us an endpoint that is always present by default, and you can throw some text at it. And as you can see here, it has definitely some characters that are not in the English alphabet, and it applies the ASCII folding filter on it and then returns the token it uses or it would use to store this input and also make them available for search. And as you can see, it strips out all these little signs on the C, on the I, on the A, and just tries to boil it down to the basic ASCII characters as good as possible. And this is pretty helpful, especially when you search for the name of the author or of in general of persons, because many people will not have these characters directly on their keyboard or don't know how to type them, or the information just gets stripped out by some system that is before your actual application, for example, by the bank. So we definitely want that all the terms that we store in our book index get through these filter, so that we can then find them easier afterwards. So this does not actually store something. It's just a command to play around with different filters and see what they would do when you apply them actually. But this data is just, it just produces this output, and it's not really stored anywhere. So I'm going to delete that. It's just for demonstration purposes. And to add such a filter so that it is always applied to our data that we want to store in our index here in the book index, we have to use a concept that Elasticsearch calls mapping. So at least for me, setting up filter and the correct mappings was not really straightforward. So I recommend that you read the documentation on both of these concepts, as there are quite some stuff to read. I will just copy over the configuration that I figured out before and then explain it. When I now run this one, we will get an error. And as you can see, it's complaining that this resource already exists. So the book index is already present, and we cannot change these settings once it's created. because there might be already data in it, and then it would all have to be reprocessed. Elasticsearch can do that stuff by index migration, but it cannot do it on an existing one. So I'm just gonna delete it for now, because so far it does not contain any valuable data. Now the index is gone. And when I now run the command, it should work. Yep, that looks good. And I'm just briefly going through it. As I said, please check the documentation, because explaining all of the concepts would go a little bit beyond the scope of this tutorial and would be more like an own course. So basically, we can define some settings for our index while we create it. Only during the first creation. We cannot change most of it later. And our settings are about text analysis, and we want to add an analyzer, which we can give whatever name we find suitable. And by default, all the data will already get some tokenizer, which is basically the way how Elasticsearch splits up different words. And by default, it will just split it by white spaces. But when we define an own analyzer, we basically override the default. So if we want to have the default behavior plus our own behavior, we have to explicitly repeat what the default is. So we have to say, okay, please use the standard tokenizer. Otherwise, there would be no tokenizer. And the same for the filter. So by default, everything that we throw at Elasticsearch will be stored also in lowercase, and also searches will be lowercase. So we have to repeat basically this default behavior here, plus we add an own filter. And again, this can be whatever name you find suitable. And then we have to define a filter with exactly this name, as you can see here. And it has the type ASCII folding. So this is basically a filter type that Elasticsearch brings by default. And I'm also going to set the preserve original here to true. So otherwise, it would only store the tokens that we saw before with the English alphabet. And yeah, I think it's a good idea to also keep the original data. You never know if you're going to need it later or not. So this is basically the configuration for the ASCII folding. And now we have to tell it, okay, where do you want me to apply this ASCII folding and lowercasing and everything? And this is the mapping part, where we basically say, okay, I want that you use this custom analyzer that I created on actually name. So I have to delete it again because this is not the correct name. Run it. Okay. And let's check it out. Therefore, I'm gonna use this string again as the name for a book. Okay, let's have a look. And you can see it does not change the content of what we store. So it only creates the tokens that we then can use for the search. So let's search for this term. And as you can see, it works because it's exactly the term as it's given here. But let's say I'm just... So, but what would happen now if I only use the English alphabet? So like this. And let's say I search for something that will not match, just to change this view here and go back to this. And you see it still returns the correct result, even so this string is clearly different from this one. So to understand why this search is successful and returns actually what we want to have. We can use the analyze endpoint again. So I'm gonna add that here. And this time we don't want to use a generic analyzer that we have to define, but we want to reuse the one that we actually applied already to our book index. So gonna specify the field, and we're gonna provide some value that we actually want to that will basically pretend to write into the index just to see what tokens Elasticsearch would generate when we provide this string. And the string we're going to provide is this one. This is basically all the tokens that Elasticsearch would generate, or did generate, in fact, when we were writing this document into our book index. So you can see it created a string representation only with ASCII characters, but it also kept the original one. And this is because of this setting, preserve original true. So you don't have to use that, but it might be helpful. And you can also see, actually you can't see it here, but let me change here some letters and run it again. And you can see they are always transformed to lowercase, which basically is the default behavior of Elasticsearch because it makes searching in general a bit easier for Elastic. And this is basically the lowercase filter that we applied here. If we would not apply it, it would just store it like that. Okay, and with that, we're basically having all the parts together that we need to transfer our data from Quarkus to Elastic. So we basically just have to make sure that our Quarkus application creates an index with the correct settings, meaning it has filters that we want to have it, and we have some statement how we can store data in the index, and we also have some way to search for values in this index, and also added some measures so that the search would actually be successful even if the user has some minor typos in it. So that's what we're going to do in the next episode, and see you there.